This third video on some common mistakes in graphical sensitivity analysis, we will look at another mistake, and that is the wrong identification of sensitivity range for the right hand sides of the non-binding constraints. Earlier in part 1 and part 2, we discussed about a company that was trying to maximize the profit by finding the optimum number of the parts to produce. In part 1, we formulated a LP model. We graphically found the optimum point. We found the profits. In part 2, we found the sensitivity range of the binding constraints, and we saw that turning and drilling are the two binding constraints, and we found their sensitivity range. In third part, we will look at the sensitivity range of a non-binding constraint. As you can see that the slack S3 for the laser is 13.6. That means this is a non-binding constraint. So the sensitivity range of the non-binding constraint, it is very straightforward if we are looking at the maximum value of this constraint. So here you can see that this blue line, it is for the laser cut, and we want to know the value of Q3, and first we look at the Q3 max and then Q3 min. So Q3 max, as I mentioned earlier, it's very much straightforward. If you just look at the graph, you can see that this line is not passing through the optimal point B. So that means whatever change we make on the right hand side of the laser hours, let's say if they are 132 right now, if we make them 168 or 180 or whatever amount we want, it will not affect our optimum solution. Rather, this line will start moving away from the origin. So it will not affect our optimum point, and our optimum point will remain the same. So the point to understand is is let's say we know that the slack at the laser is 13.6 hours. So if I decide that this right hand side, this laser cutting hours should be increased to 9.x1 plus 4.1x2, I increase one is this 132 to, let's say, 140, that is plus 8 more hours. So it will do nothing, it will have no effect on the optimum solution. Rather, our slack will increase, and slack will now become 13.6 plus 8 hours, and that is 21.6. So that means the maximum, the upper limit for Q3 is, it is unbounded. It has no upper limit, because it is not affecting our optimum point. Now we see how we can find the minimum range of the uh, laser cutting hours. And again, if this is our graph, this is the optimum point B, this is, and the point B we know had the coordinates of 7.16 and 12.98. Now we see, now we want to see that how much the laser R can be reduced, and without having an effect on our optimal solution. So by reducing the laser hours from 132 to a lower value, means that this blue line will start moving towards the origin. So the lowest point this line can achieve is this point B. So this is the point, this is the lowest point uh, where the laser cutting hours can intersect with the point B. Because if I move this line further away from B downwards, so this will change the whole visible region, or in other words, this will affect our optimal solution, previous optimal solution. So we can't do like this. So the minimum position of this line where this can intersect with the other two constraint is this point B. So B is the point where we can have the minimum value of the laser cutting hours, and we know that point coordinates of B are 9.16 and 12.98. So we'll just plug in the values and we will find that 9.1 into 7.16 plus 4.1 into 12.98 will give us Q3 minimum. And if we do the maths, then Q3 minimum will have a value of 118.3, and the available value was 132. That means the allowable decrease can be 132 minus 118.3, something around 13.62, because I have rounded off some numbers here. And the allowable increase, as I discussed on the previous graph, it is unlimited. So while finding the ranges of the non-binding constraints, you have to keep two things in mind. The first thing is that because these constraints have slack or at the optimal point, so they have no bound for the upper value and no bound for the upper bound. They have no upper bound. And for the minimum value, we, we can move this with this constraint to the optimal solution, and we can find their value by plugging in the coordinates of our optimal solution. So that was that's all about the non-binding constraint. It was a short video so that you should understand the concept that what happens when you change the right hand side of the non-binding constraints. Thank you.